During the Second World War, access to clean water was often more dangerous to secure than food or ammunition. Troops advancing through bombed cities, islands and deserts routinely encountered water sources that were polluted, brackish or biologically unsafe. Boiling helped, but fuel was scarce, and boiling did nothing to remove salt, heavy metals or chemical contamination. Out of this pressure came an emergency solution, taught quietly in field manuals and survival briefings. A water still built entirely from scrap metal and battlefield debris. It required no specialized equipment, relied on basic physics, and worked anywhere heat could be generated. This was not a laboratory device. It was a life-preserving system designed for worst-case conditions. Military engineers relied on distillation because it solved multiple water threats at once. World War II survival doctrine recognized that water dangers came in layers. Pathogens caused illness, salts caused dehydration, and chemical runoff from explosives made some sources outright toxic. Filtration alone could not address all of these problems. Distillation could. By heating contaminated water until it evaporated and then condensing that vapor elsewhere, soldiers could separate pure water from nearly everything else. Salts, microbes, and most toxins stayed behind. This made distillation uniquely valuable in environments where water quality was unknown or constantly changing. The still was designed around scavenged metal rather than issued gear. The core components of the World War II emergency still were simple. A metal container to hold dirty water, a way to capture steam, a separate surface for condensation, and a clean vessel to collect the result. None of these needed to be purpose-built. Soldiers used helmets, ammunition tins, ration cans, engine parts, and even flattened scrap metal from wreckage. The design varied, but the function remained constant. Heat was applied to the dirty water container. Steam rose and was guided or trapped against a cooler metal surface. Condensed droplets ran into a clean receptacle. This adaptability mattered. In survival conditions, the ability to substitute materials is just as important as the method itself. The helmet still became one of the most practical field variations. One of the most widely taught versions actually used a steel helmet as the boiling chamber. Contaminated water was poured into the helmet and heated over a fire. Another metal surface, such as a mess tin lid or a bit of scrap aluminum sheet, was suspended above it at an angle. As steam rose, it contacted the cooler surface, condensed, and ran downward. A small channel or folded edge guided the distilled water into a clean cup or canteen. The setup required careful positioning, but once established, it produced drinkable water steadily. This method worked even with salt water, making it especially valuable in coastal and island operations. World War II manuals emphasized that condensation efficiency mattered. A hotter boiling chamber produced more vapor, but condensation required a temperature difference. Soldiers learned to cool the condenser surface deliberately. This was done by exposing it to open air, splashing seawater on it, or shading it from direct heat. In cold climates, ambient air did most of the work. In hot regions, even a slight breeze improved output. Modern users can apply this by ensuring the condensation surface stays cooler than the boiling chamber, increasing water yield without burning more fuel. The still also worked using solar heat when fires were risky. In situations where smoke or firelight risked detection, soldiers adapted the still for passive heating. Scrap metal containers were placed in direct sunlight, sometimes painted dark or blackened with soot to increase heat absorption. A metal sheet or can lid acted as the condenser angled to allow droplets to run into a container. While slower than fire-based distillation, solar stills produced water silently and continuously. This variation demonstrates the versatility of the concept. Heat does not need to be dramatic. It needs to be consistent. World War II field training noted an important caveat. Distilled water, you see, lacks minerals. While it's safe to drink for a short time, relying on it exclusively over long periods could actually lead to electrolyte imbalance. Soldiers were instructed to mix distilled water with small amounts of uncontaminated water whenever possible, or to add food sources that would help replenish minerals. This level of understanding, well, it really underscores just how seriously the method was treated. For modern survival use, distilled water is best seen as a purification step, not a complete hydration strategy. What made this World War II water still reliable was not clever design, but, fundamental science. Evaporation and condensation work the same everywhere. Scrap metal was sufficient because the process did not require precision, only a temperature difference and containment. This is why, the method appears repeatedly in post-war survival training. It's resilient to error and material shortages, really standing the test of time. So, to recreate this method today, you'll want to identify a metal container that can safely be heated, a separate, clean collection vessel, and, some way to condense steam. It's important to focus on sealing any gaps so the vapour travels toward the condenser. Remember to keep the condenser cooler than the boiling chamber. And, just be patient. This approach actually works with questionable freshwater, saltwater, and even chemically tainted sources, where, honestly, filtration alone just isn't enough. World War II's emergency water still was never meant to be elegant. It was simply meant to work when nothing else could. Its real strength lies in its simplicity and adaptability. Understanding it isn't about reenactment, really. It's about recognizing how people solved life or death problems with limited resources and clear thinking. If this deep dive into wartime survival engineering added value to your understanding of practical history, do consider subscribing to Backyard Wisdom. Share this episode with others who care about self-reliance and historical knowledge, and help keep these proven techniques alive for the future.